day, and they'll be able to see it at a remote site, so that makes it kind of interesting. This little panel, you'll notice that one end has got a window, but there's panels in here that are about 5 by 6, and they're not really meant for windows as such. Those are test panels that we can move material in and out. So this is an old technique, stack wall as we call it in Manitoba. Our colleagues and friends to the south of the 49th parallel refer to it as cordwood masonry. And that's just log ends with mortar in between, and we've got a smaller building outside that we're just finishing up that we ran a workshop here about 3 weeks ago or so, where we're doing that and re-establishing the kind of a newer cordwood building because we have an old one here across the road. But so basically these panels, we can move them in and out, we can do anything with them. This one was for a study to look at the R value, the thermal resistance. And so we have exactly the same panel on the north side of the building, so there's no sun or anything, so we can do those comparisons. The data that we got from this now forms the basis of being able to get approvals in Wisconsin, for example. So they use these data for approvals and whatnot. So we've been able to work with the builders to help them out, to do that kind of work. So that the buildings are, yeah, we can do a quick tour of the buildings. I just want to, how much time do we have, Gary?
We're at 9:30.
9:30? Okay. So some of the axial load, lateral load, and racking. So that way we can do the tests. We've just finished up some work with a company here in southern Manitoba, and now this facility, we're working with CCMC out of Ottawa, who you're familiar, I'm sure a lot of you are familiar with in terms of the evaluation studies and that. So that's one service, if you will, that we can offer the industry, because the whole issue is to try to work with industry to provide value added and make those connections. So they can come work with us, then we can work with them to get their evaluation numbers so they can get their product into the marketplace. Right now you can't technically, while there are some SIP panel buildings within the city of Winnipeg, the planning examination department has now basically said they're not going to allow SIP panels unless there's a CCMC number, so that's a good incentive to do that. So it's great to be able to work with the industry to be able to make those connections.
There's a sample of SIP panel over there if you just want to explain a little bit.
There's some of them stacked up behind you over there as well that were tested. So if you want to have a quick look, that's basically our window into the wall. You can see the straw bale, you can see there's a fabric, not a fabric, but a fiber mesh on that in there, and that's really just to provide some crack resistance within the plaster. I liken it to ripstop nylon, basically, so you get a weave in there, and then that just provides you with a little bit of resistance to tension cracking. It really doesn't add anything to the structural behavior of the wall, because the structural behavior is really a function of the stucco bonding with the straw bales, and that's it's surprisingly quite a strong bond. One of the research pieces that we're looking at, though, is what happens to that bond over time. If there's durability issues and whatnot, if you lose some of that, then how does that perform, and what's the impact on load carrying capacity? So on a day like today, when there's a light breeze and that, it's a nice place to come out and work, be out here. And we need to mow the lawn, I see, but we've got a few things going on. Right behind you over there are some test plots with a landscape architecture student that I'm working with on green roofs, and she's looking at the different types of flora and different types of plants that are used within Manitoba to see how they're going to respond over the winter and whatnot. And so that's an ongoing project. And the idea of the village, in my mind, the vision has always been this is not just about engineering, but it's about all of us working together, so it's a whole variety of things that can happen out here. These small buildings, then, these two that you see here with what looks like white siding are product called Octaform, which has a foam outside layer, 4 inches of EPS foam, and then there's concrete on the inside. This building right here is actually open if you want to poke your nose inside. There's nothing exciting to see in there. But once the work is done, it would, we thought for income generation we could rent these out to grad students. They're actually pretty big.
Nice housing.
And we also have a new stadium being built over here, so we thought, well, we could have sort of a tailgate party on steroids. We could rent these out for football games, but nevertheless, always trying to find revenue. Right? So these buildings then are all monitored The floor systems are the same. The roof systems are all identical in all of the buildings. So we have, that way we're looking strictly at the walls, basically. We can eliminate the floor and the roof out of it. They're monitored for temperature through the wall, relative humidity, and energy use. So the nature of the study basically is to say, how much energy does it take to keep this building at, say, 18 degrees C? And then we can do that comparison. It's really interesting for the industry to be able to see that. And if you're from Winnipeg, and I know some people have heard my old joke, but if you're from Winnipeg, the W in Winnipeg stands for wholesale, or not willing to pay, you know, so we're always trying to find the lowest cost and what's more affordable. And so with a 6 cent per kilowatt hour energy rate here, it's a challenge to find systems that are economical. So we have the octoform system, which is concrete. Back behind us there a little bit, you'll see another OSB building. That's polyurethane structural insulated panels. So those are SIP panels. Then over behind us here is blown-in cellulose, or dense packed cellulose. So that's locally manufactured cellulose product from here in Manitoba, which is all just recycled newsprint and whatnot. Then there's another building on the other side of the greenhouse, which again, they all look the same, which is our baseline or benchmark building, which is a standard 2x6 stud frame wall with fiberglass bath insulation built to a Manitoba Hydro Power Smart standard. That provides the benchmark. So now each company can kind of compare what they're doing in terms of how their building relates to that. Because part of this is, if you go to Manitoba Hydro for a Power Smart support, financial support, they base it all on our values and you can see what the difference is, and that's where you get your rebates and whatnot. So that's really important. The last pad over there, it kind of looks like an RV park, you know, everything's all wired underground, and then you have little pads. So that pad over there is going to be the hempcrete one, which you'll get a chance to run across the road there with Jeremy and have a look at that. Okay. Then the next thing we're working on here is a solar energy greenhouse that you heard about yesterday. So we can cut it here. Whoa. Close quarters.
Feedback at the rock pots here.
Takes me back to my session yesterday afternoon on greenhouses. This is the one that Mo was talking about. So this is a variation, if you will. There's nothing different in terms of the shape, the variation on the so-called Chinese greenhouse. The difference being that that all these frames are manufactured. They're manufactured locally, and they're all manufactured the same. They're fairly heavy. I mean, you could argue, and you'd be right, that you don't need that strong a structure to support the snow loads in Manitoba. But part of this is to be able to deal with the cost. So therefore, the local manufacturer, High Fall Construction here in Manitoba, in Winnipeg, then has everything set up in their factory. They just manufacture exactly the same frame all the time. So while the load carrying capacity of these 3-inch tubes is going to be a little bit greater than what you might need here for Manitoba, you get into parts of BC or Ontario and whatnot where your snow loads and that are greater, then they're going to work fine. The concept behind this is to find something that is easy to assemble. So if I'm in a greenhouse business, or Gary and I are in greenhouse business, we want to get this thing up as fast as we can. So I want something that's, you know, tab A fits into slot B with bolt C and nut D, and I'm done, and then we can get on with what we want to do. So this whole frame went up in about 3 hours with about 4 people. So you just stand it all up, you bolt it together. The spacing of the frames can change. That's totally a choice based on design. The only thing that will change would be the base tube. And then the arch, everything's facing south here. We're testing out this fabric that this particular company uses. It's translucent as opposed to transparent. It's a little bit heavier. We have a pyranometer outside, and then we'll put a pyranometer inside here to measure the difference in solar radiation that we're getting. The intent of this then is to be able to provide a system that you can set up virtually anywhere. So here we're on a concrete pad, or sorry, on a gravel pad,